Hey guys, today we're going to be working on 10-1, which is graphing quadratic functions. And for this one, there's a few new things that we need to know. First of all, we need to know what kind of form our problems are going to be written in. And for this lesson, most of our problems are going to be written in y equals ax squared plus bx plus c form. And that's important to remember because later on, when we're trying to find the vertex or even the symmetry or the axis of symmetry, we're going to need the A and the B. We're going to need to identify that to move on. So there's a few new vocabulary words that we need to know here. Parabola being one of them. And if you could remember, a parabola is a line, a graph line that kind of is a curve. So what we're going to do is we're going to talk about the two different kind of parabolas you're going to see here. Now I'm going to show you two different equations to start off. So I'm going to write this one down, which is just an example that's going to be written in this form up here. And it is y equals 2x squared minus 4x minus 5. Now the important thing to understand here is that this number right here, this 2, where the spot of A, that tells us what kind of parabola we're going to have. So if you have a graph and you have a positive number here, you're going to have a parabola that's going to open upward. So the parabola is going to be opening towards the top. So that means the vertex, which is the end right here, is going to be low. So it's actually going to be, there's two different terms for this. For a parabola facing this way or that's opening upward, we call this the minimum. Okay, that's the minimum or the vertex. It is the minimum vertex. Now, just the opposite way, if we have another equation that has a negative 3 or a negative number as its A, such as this one that's negative 3x squared minus 6x plus 4, if you end up graphing this one, it's going to look something like this. Now, these graphs aren't ideal for these certain equations. There's just an example. So in this case, the vertex is right here, and since the graph opens up, the parabola opens up downward, then instead of calling this the minimum, we call it the maximum. So that's the first thing we need to know. So now we're going to talk about the axis of symmetry. Now the axis of symmetry is really important for this lesson. It's the main part of this lesson. So what I've done here is I've sketched this graph right here, this parabola. Now obviously since it's opening upward, we know that whatever equation this is has to have a positive A, which makes it open upward. Now it's not important what the equation is at this point. Some of the questions are going to ask you to find the axis of symmetry. And what the axis of symmetry is since the parabola is perfectly symmetric, which means that if I cut it in half, this half mirrors this half over here. So the axis of symmetry is the line that cuts this directly in half. So in other words, the axis of symmetry in this parabola is about right here. Now the axis of symmetry should only cross the x-axis. And as you can see from this sketch right here, or this graph, it crosses the x-axis at 2. So the axis of symmetry, if you were to write like this, is x equals 2. That would be the axis of symmetry here. The problem, it might seem like a really easy problem to do. The issue here is that most of the time you won't have the graph. It's easy to see when you have the graph, but most of the time you won't be able to see the graph. What you'll have is just an equation, and that's what we're going to go ahead and do next. One more thing that's really important to understand here is that the relation between the axis of symmetry and the vertex. Remember, the vertex is the highest or lowest point depending on which way your parabola opens. In this case, it's opening upwards, so the vertex is going to be on the bottom or the minimum. And if we graph this point right here, you'll see that it is 2 and negative 4. And that is the vertex. So this is what this vertex equals. So it's very important to understand the relation between the vertex and the axis of symmetry is that whatever the axis of symmetry is, where it crosses the x-axis, should be directly over or under the vertex. So in this case, x is 2, and the x in the ordered pair is also 2. So these two numbers will always be the same, and that'll be helpful later for when we don't have the graph, we have the equation. So here we have our equation that we're going to be working with, and we're going to be finding the axis of symmetry and then finding the vertex for it. So as you can see, it is a negative. The A spot in here is negative, which means that the parabola is going to open downward, which means it's going to have a vertex that is a maximum, not a minimum. So we can easily graph this by creating a chart, plugging in our x's, and then finding our y's. However, that's going to take a long time, and to graph it, it's going to take even longer. Graphing this, if you ever get confused, graphing it will always make it so it's easy to find your axis of symmetry. However, it does take a long time, so it's a little bit of a time waster. Instead, to find the axis of symmetry, we're going to use the formula for it, which is x equals negative b over 2a. Now remember, I wrote this up here to show you the form that all these problems are written in. And the reason I wrote that is because now you can see we have b and we have a. And we're going to plug these two values in. So, for example, for this equation, it's going to be x. We're going to use the axis of symmetry formula. It's going to be negative, and we have b on top. And we can see that b is right here. It's bx. In this case, it's negative 6x. So b in this equation is negative 6, and that's what goes on top. Then we have 2 times a. And in this case, a is right there, or in this case, right here, negative 3. So this is going to give us our axis of symmetry. So 2 times negative 3, we know is negative 6. Negative 6 goes into negative 6 one time. And because they're both negatives, a negative divided by a negative is a positive. However, you still have the negative out here, so it means that it's going to equal negative 1. Okay, so our axis of symmetry is negative 1. So why is this important? It's important now because we didn't have to graph it, and we found out really quick that our axis of symmetry using this formula is negative 1 without having to graph it. We're not having to make a table. Our next step is to find the vertex. So remember that our vertex and our axis of symmetry share the same x. So for our vertex is always a point, so it's an ordered pair, x and y. Now we don't know what that is yet, and we can't tell from just looking at the equation. However, by finding that axis of symmetry where it crosses x and cuts right down the middle, we know that x in this case is negative 1. So it's kind of an easy way to get us started. So now that we know that, all we have to do is plug in x, which is negative 1, and we know that now, into this equation. So that's what I'm going to go ahead and do here. It's going to be y equals negative 3 instead of x. I'm going to write negative 1 because that's what it is. Minus 6 and negative 1 here plus 4. So this is kind of a tricky part, and I just want to make sure you guys remember this from last time and what we talked about in the classroom. You know that this negative 1 has to be broken out of these parentheses, and usually it would be done by this negative 3 over here. However, most of the time we don't have an exponent out here. And remember that exponent is higher up in the order of operations, so this is what's actually going to break the negative 1 out, not the 3. So this is the power, the second power, or the square, is going to break the negative 1 out. So negative 1 times negative 1 is 1. And negative 3 times 1 is going to be negative 3. Over here we have negative 6 times negative 1. We know two negatives make a positive. And that's 6 plus 4. And we know that all this added up, that's 10 minus 3 is going to be 7. So now that I have my y, I know that that replaces the y here. And my vertex is going to be negative 1 and 7. I know that you can find this a lot easier by graphing. However, I hope you understand that within the short amount of time, I found both of what I needed and other things like that.